Okay, so block day, it's Halloween, continuation of the notes, but it's a more of a break than, it's like saying it's a continuation is a little bit misleading. Like there is something new happening today. Bathtub problem. Assume that the number of liters of water remaining in a bathtub varies quadratically, meaning like a parabola or like the ax squared plus bx plus c, with the number of minutes which have elapsed since you pulled the plug. Okay, I guess that sort of makes sense. So the water is draining, but it's not draining linearly, it's draining quadratically. If the tub has 33.4, 16.6, and 4.6 liters remaining at 1, 2, and 3 minutes respectively, since you pulled the plug, write an equation expressing liters in terms of time. That's a mouthful. This is a lot of information to make sense of, so I think I would write it as an ordered pair or like a table to kind of help organize my information. Almost always time is the independent variable, the x variable. So that's 1, 2, and 3. And my y values, like respectively, meaning they match up. So 33.4 goes with 1 minute, 16.6 goes with 2 minutes, and 4.6 goes with 3 minutes. And even before we get an equation, I think that makes sense, right? Like 1 minute after you pull the plug, there's 33 liters left. A minute later, there's 6. Like so, the water's going down. So this makes sense so far. Write an equation expressing liters in terms of time. Okay, well, y is in liters. So I need y equals, and they already told me it's quadratic. So I need to come up with a and b and c. And there is a way to do this by hand, but it's ridiculously hard. We're going to use the calculator. So we're going to enter data into the calculator. So we're going to enter data. I'm going to outline the big steps first, and then we'll go back and put the details on there. Then we'll get an equation. And then we'll use the equation. And all of these are calculator things. So you're not doing any math, but you are making sure we know how to use the calculator. So today's lesson is more like, where are the right buttons to get this to work the way I want it to work. Okay, and again, I'm teaching this as if people are using the 84. I'm certain the Inspire will do it. I just don't know how to make the Inspire do it. So if you're an Inspire devotee and you want to stick with that, that's fine. You either figure out how to do it, or I'm sure you could Google it, and there's probably a YouTube video of somebody explaining exactly how to do it. Okay, but the TI-84 way. Let's see. We want to do some stuff with statistics. I've got numbers I want to deal with. So I think there's a button on there somewhere that says Stat.
Do you clear the calculator?
Like wipe it all out completely?
Yeah.
If you want to clear the calculator, second mem, then you can sort of figure out. Reset would be wiping it out. All memory, reset, takes a second. Second mem, and then kind of follow the directions from there. You don't need to do that, but if there's a bunch of junk in your calculator and you want to get it out, that's one way to do it.
There's usually already a graph that somebody else had, and then it
yeah, but if there's a graph, just clear the graph. All right, back to what we want to do. Stat. And let's see. I want to put in some numbers. So which of those options do you think would sound like be best for putting in numbers? Even before setup. It's not. I don't need to calculate anything yet. I'm definitely not doing any tests yet. I just need to edit the list. So stat, edit, stat, edit. So I think it's easy to see, or at least it's easy to keep up with. X's go in the left-hand column for L1. And then the Y's go in for L2. Okay, what the calculator is going to do is fit a parabola onto those 3 points. So rather than us trying to figure out, well, what curve would go through those, the calculator can do that, and we're going to ask the calculator to fit a graph through those points. So that's the get equation part. So let's exit out of there. This is kind of what feels weird, is like after you get them in, we're still working with them, but in a different way, so quit. I guess I should say not exit, but quit. Second mode is the quit button. Second quit. They're still there, so if you went to stat edit, there they are. So like when it's time to go to another problem with different points, stat edit and put them in there. Second quit. Okay, now I want to figure out how to get the calculator to give me an equation. So we're still doing stat stuff. I don't need to sort anything. I don't want to clear the list, right? That's pretty clear what that would do. I don't know what setup editor even does. So let's scroll over to Calc. And here's where our options are. Calc. Have we done regressions? I think we did that in pre-cal. Have you done it before in here? Okay. A regression, that's a fancy word for fit an equation to the data. So a linear regression fits a line to the data. That's kind of convenient. They threw the ax plus b on there. So which option do you think we want to use if we're doing parabolas? The quadratic regression.
5. Quadratic regression. Quadreg.
Regulate your quads. Quadratic regression. Regression just means fit an equation to your data. But you have to tell it what kind of equation. You want to fit a line, you want to fit a quadratic, you want to fit a cubic, a quartic. There's another linear, there's natural log, exponents, powers, there's all sorts of stuff. We don't want to do that stuff yet. Let's go with quadratic regression. And then you hit enter. And everything should fill in automatically. Like it should be the stuff you want. Like if you've gotten these backwards, like then this is where you would fix it, but that, like just put them in the right spot and this will take care of itself. You don't have to put in anything. You can just go down to calculate. Like you don't have to worry about typing things in, frequency list, store, regression equation. Nope, don't do any of that. We can go to, actually, I'm learning something here. Let's just go with calculate for now, and then we'll see what happens next. So we'll press calculate. It thinks for a minute. It's pretty quick. Like you, again, this is something you could do, but it would take forever. Thank you. Yeah, let me get you. There we go. So, and it's nice that it like tells you what, like it's found everything, and it tells you what it's found. It's ax squared plus bx plus c. So when we hit calculate, we've got y equals 2.4 x squared plus, or minus in this case, 24x plus 55. So we've got our quadratic equation now. Okay. Let's input something before we hit calculate. We want to use that equation. And so what I'm about to do is optional. because, like, we've got what we need, right? Now we could go to y equals, we could put that in, and we could find vertex and intercepts and answer all the questions. Like, from this point forward, it's exactly like we've already done. It just took us a little while to come up with the equation. Okay, let's back up a second. Let's follow these steps again, and there's an extra step in there that will make life a little easier. Second quit. Follow the same steps. Stat, calc, quadratic regression. When it comes down to store the regression equation, like, I'm probably going to want to graph this, so it would be nice if, instead of me writing down all that stuff, you can get the calculator to put it in for y1 for you. So when you get to store regression equation, we're going to go to vars. Let's see, vars is over there on the right. Get my frozen face off the screen. Let's see, vars is right there. And we want yvars. Vars, yvars, function. And then this is where you can put it wherever you want it. Like, we're only going to have one equation, so we'll put it in for y1. But you could, if you had something else going on in your calculator, you know, later on you've got doing something really complicated and you got 3 equations in there already, then you could save this to y4. So y1, or whichever one you like, press calculate. Gives us the same answers, but now if you go to y equals, it's like, oh, magic. Now, 2.39999999999. So the calculator is a little more accurate in the y equals, but 2.3 with a whole bunch of 9s, I'd say that's pretty close to 2.4. And it landed on negative 24x and 55, exactly right. So that saves you the hassle of typing in numbers. And the numbers are small, no big deal. But if you get some crazy numbers here, it would be nice if the calculator would put them all in there rather than you typing them all in there.
What do you input? How do you input like a y1 to the store equation?
How much water was in the tub when you pulled the plug? So when you pulled the plug, how are we going to answer this question? Don't tell me it's something on the calculator, but what's it asking? Okay, perfect. What is y, how much water, when x equals 0? Because that's when we started. So I need y of 0. So I'm going to plug 0 into my equation, and I'm going to argue I don't need a calculator for this particular problem, because it's 55. Now, if you want to go in and type 2.4 times 0 squared minus 24 times 0 plus 55, that's fine, but we'd really rather you have your math brain engaged so that you can see that this is 55. And we're in liters, so 55 liters. So we started with 55 liters. When will the tub be empty? So when is a time question. How will I know when the tub is empty? Well, x is time. You're on the right track, though. When y is 0, because y is how much water there is. So I want to find time when y equals 0. So 0 equals 2.4x squared minus 24x plus 55. I could try to factor that. I'm almost positive that won't factor. I could use the quadratic formula, which would be kind of a pain, but it's right there on the graph. Let's try to draw this picture here. You know what? I'm going to change my window. I want to go up to 55 because I want to see. I'm going to go up to 60. I want to see what's happening.
So how did you get to the graph?
sorry, to the graph, I hit graph. For my window, I'm going to change the x's now, because I don't need to see when x is negative, because that was like before the experiment started. So I'll make it -2 just so I can see the axis there. There's a decent picture of what's going on. So it started at 55. It drained out. It looks like I have 2 zeros. So which zero am I looking for where the tub will be empty? Pardon? The first one. Right, this is a modeling problem. And so it assigns the parabola to everything, but the only part of this graph that I really care about is this part. That's the parabola that I care about. After that, we're empty. So there's where the tub is empty. Here's where we started. And so, yeah, the calculator gives me the full picture, but I don't need the rest of this stuff. Like that, I don't need any of that stuff. I mean, yeah, it shows up on my calculator, but I need to understand that this is not what happens, right? You don't, after the tub empties out and a couple seconds later it like starts magically filling up, that would be like horror movie type stuff there, right? Like that's not what really happens. Once it drains out, you're done. Okay, we can also use the calculator to find a zero. Second calc. Oh, the second option there is 0. Second calc 0. If you make it that far, the calculator will walk you through the rest of the way. Left bound. Do you know what left bound means? What it's asking for there? It means get left of the 0. And you can get as far left of the 0 as you like, but you're going to be having your... It's like, you want your calculator looking in a narrow window because it'll work faster. If you give it a big window to search, it'll still find it. It just takes longer to find it. Now, it's like a matter of seconds or tenths of seconds, so it's not that big a deal, but it'll be a little quicker if you get close to the 0 for your left bound. Right bound. So get to the right of the 0 and press enter again. And again, you can go way over, but don't do that. Just get just right of the 0. Press enter. And guess the quickest thing is to just press enter again. And there's our 0. At x equals 3.557. And time was in minutes, so 3.557 minutes is that 0.
Can you show how you did how you got to doing the write down and all
Yeah.
that?
Yes. So, second calc, and I want to find the 0, so 0, and then it prompts you. So if you can get to second calc 0, or really just second calc, because you would know you're looking for a 0, left bound means you're going to scroll to the left of the 0 and press enter. Right bound means get to the right of the 0 and press enter. And then you can just press enter again for guess, 3.557. And it kind of confirms that y equals 0. All right, everybody got that on your calculator? What does that, there's another 0 on there. What does that other 0 mean for this problem? What are we doing? Nothing is the answer. Nothing is the answer. I don't understand. Do you want to do all this class? Okay. That's probably because you don't do anything. Okay? I walk you through step by step. Now you're too far behind. So we'll have to go on. and I'll come back to you in a minute. It's very frustrating. The rest of you, thank you very much for keeping up and wanting to do well. My question was, what does this other 0 mean in this problem? That's kind of a trick question. Nothing. It doesn't mean anything. In this problem, that 0 doesn't mean anything. So you could go find it, but that's pointless. Like after the water has drained out of the tub, it doesn't, magically bubble back unless you've got a sewage issue or something. Okay, are we okay with second Calc 0?
Well, mine, you can't even see the graph.
Uh-oh. D. What is the lowest number of liters the model predicts? Is this number reasonable? Why or why not? So what's the lowest number of liters? Where does the lowest happen on a parabola? At the vertex. So vertex, x-coordinate of the vertex. You know what? While we're using our calculator, second Calc, which one of those words means lowest? Minimum. So let's just use second Calc 0 minimum. Or not second Calc 0, second Calc minimum. And then it'll walk you through the same stuff. Left bound, so get to the left of the vertex. Press enter. Right bound, get to the right of the vertex. And you don't know exactly where the vertex is, so just make sure your left bound and right bound are far enough away that you're away from the vertex. Does that make sense? You're going to mess it up if you pick a left and a right bound on the same side of the vertex. Guess, just hit enter again. And so my minimum happens when x equals 5, but that's not the lowest number of liters. The y minimum is negative 5 liters. We kind of talked about this already. Is that number reasonable? No. Why not?
Because you can't go below what the other.
Right, I don't know how else to phrase this. The tub is empty at 0. So past 0, it doesn't even make sense. So we sort of mentioned this already when I highlighted that part. Anything else, it's part of the model, but it's not what's really happening. Part E. What is a reasonable domain and range for this problem? So I kind of have it highlighted. Naomi? What's that? Yeah. So what x values makes sense for this model to actually match the problem that's going on? What x values should we look at for the domain? So 0 is when we start the timer, when we pull the plug. And when do we run out of water? 3.557. After that, the model is pretty meaningless because you can't drain negative water. I don't even know what that means. The range is how much water there is. Well, be careful. This is where some people are tempted to go 55 to 0, but you got to do smallest to largest, 0 to 55. Okay, let's start another one to make sure we're okay, because that was a lot of buttons, a lot of calculator work. So, memorize. I would say you have to know where the calculator buttons are, yes. Definitely. Now, after you do some, it's going to be, I don't think it's going to be as hard as you think, because it almost always starts with stat, and then either edit or calc. And once you make it that far, you can remember where the stuff is. All these equations, all these questions, that's not memorizing. That's just reading and understanding what they're asking. But, muscle memory doesn't kick in after one problem. So let's turn to number 6. And let's try the same thing here. On a trip to St. Louis, you visit the Gateway Arch. Highly recommended. Super cool. Since you have plenty of time on your hands, you decide to estimate its height, because of course you do. You set up a coordinate system with one end of the arch at the origin. I was going to do this already. Sketch a graph of the situation. So, I don't know if you've seen, or at least seen pictures of the gateway arch. It's not actually a parabola, but close enough to do a word problem with. The other end of the arch is at x equals 162. Okay, so we put one end at the origin. That kind of makes the math a little easier. The other end is at 162, 0. To find a third point on the arch, you measure a value of 4.55 meters when x equals 1 meter. So it's telling you that there's a point here that's, this is probably not the scale, but 1, 4.55. You assume the arch is parabolic, which means we'll be headed toward a quadratic regression. Find the equation of the underside of the arch. Well, maybe before we do that, I like to list these points as on a table because that's how they're going to be listed in the calculator. So 0, 0, 1, 4.55. And by the way, these do not have to be in order as long as they're all there. Okay, so we've only done this once. Do you remember where to put that table in the calculator? Stat and edit. And 0, 0, 1, 4.555. Or no, just 2 5s, 4.55. And 162, 0. So stat edit gets them in there. And then I'm not writing all the steps. I'm just, usually if you remember stat edit, you'll figure it out from there. And if you can remember stat, what do I need to do next? Calc. Again, I don't remember them. I remember it's under stats. So if I can get there, then it's like, oh yeah, calc. And we said we wanted a quadratic regression. Quad reg. And this is where some of you will just have to press calculate. Oh man. Yuck. So this is where if you can store them, it's much better. So you guys that have a calculator that'll store them, it's nice. If you don't, you're going to have to write this stuff down and type it all in there. Yeah. Let's see. Well, since we're using this, let's go like 5 decimal places. Remember, because you don't want to round to the end. So yes, I want answers to 3, but that means all the stuff before 3 needs to be more accurate than 3. What about that 1.26 e negative 9? Do you know what that means?
Yeah.
It means times 10 to the negative 9th. So if you wrote that as a decimal, is this middle school? I don't think elementary school does this. What would that be as a decimal? Yeah, I don't know. I'm going to lose count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 8 zeros, and then so to the nearest 3 or 4 decimals, that's pretty darn close to 0. So pay attention. When you get times 10 to the negative 9 or times 10 to the negative 12, you don't have to put that in the calculator because that's 0. All right, so there's my equation. What is the x-coordinate of the vertex? Oh, we can do this. This is easy. Negative b over 2a. Or, what's the calculator way? Second Calc. If that's all you remember, that's good enough, because you'll see that maximum is one of your options. And that max will lead to an ordered pair. So this one is the x-coordinate. And the maximum height, that would be the y-coordinate of the vertex. Okay, so we'll go to y equals, and then we type in it was negative 0.02826 x squared. I'm going 5 decimals just because I know if I carry 5, when I round to 3, I'll still be good. Plus 4.57826 x. And I'm not going to put that plus 0 at the end because that doesn't change anything. And I'm definitely not typing in 1.26 times 10 to the negative 9. So if you want to see it, that looks like a line, but that's because how far out do I need to go? What kind of window do I need to look at for this problem? What does my x max need to be? 162. Maybe I want to go a little past that so I can see it. So I'm going to go like negative 5 to 170. I have no idea how tall this arch is, so I'm going to go with 100 to start with, and I have no idea. Oops, nowhere near. But it's a game of guess and check. 300 maybe? There we go. 300 was plenty. You could maybe change that to 200. Doesn't matter. While I'm here, second calc max. Left bound. Oh, this one's kind of tricky because it seems like it flattens out for a while. So make sure you're definitely to the left and definitely to the right. And then guess anything in the middle. So there's my x coordinate of the... Wait, I probably should have been able to get that without using the calculator, right? Because I'm pretty sure the x-coordinate of the vertex should be right in between 0 and 162. So 81 meters. And the height is 185.425. Then I'll leave you to try. So your assignment is 5 through 8, or 4 through 8, or however many are left. We did 4. So 5 through 8. 5 through 8. And we'll look at those on Friday.